Welcome to a deep dive. This is where we take your sources, pull out the most fascinating nuggets of knowledge, and really help you get up to speed on what's happening right at the frontier.
Yeah, digging into what's actually working.
Exactly. And today, we are pulling back the curtain
Yeah.
on what is really going on inside, top AI startups when it comes to prompting AI agents. Our source material is just gold insights surveyed from over a dozen companies actively building this stuff, shared directly from their trenches.
Real world stuff?
Yeah. So our mission is clear. Go beyond the basics of prompt engineering, understand the practical tips, and, maybe more importantly, the emerging architecture of prompting for these vertical AI agents.
Right.
Honestly, sometimes it feels like navigating a totally new frontier, or even like managing a person. And the tooling, well, it feels a bit like coding back in, 1995.
Yeah, the tools aren't quite all the way there yet, that's for sure. And what makes this deep dive particularly valuable, I think, is that seeing actual production-level prompts for these vertical AI agents is incredibly rare.
Yeah, you never see them.
You really don't. They're absolutely considered crown jewels, core IP for these companies. But thankfully, some pioneers are starting to share insights. And we've got a prime example to unpack today that gives us a real window.
Okay, let's unpack this. Let's jump straight into that prime example then. It comes from a company called Parahelp.
Parahelp.
They specialize in AI customer support, powering agents for some big names like Perplexity, Replit, Bolt. And what's amazing is they were actually willing to share their prompt with the researchers behind our source material.
Which is huge. And when you first see this prompt, the initial reaction is usually, wow, this is long.
Long? How long?
The source mentions it's like 6 pages just scrolling.
6 pages. Wow.
But that length isn't just fluff, right? It's packed with these key structural elements that really define the state of the art in production prompts today.
Okay, so what are those key elements?
Well, first, they meticulously set the role of the LLM. It's not just, be a helpful assistant. It's super specific, like, you are a manager of a customer service agent. And then they break down exactly what that means in bullet points.
Okay, defining the persona very clearly.
Precisely. Second is defining the specific task, maybe something like approving or rejecting a tool call within this whole orchestration of agent interactions.
Got it. Role, then task.
Then, after that, there's a high-level plan, often laid out in clear, numbered steps, so the LLM knows the sequence.
Like a procedure.
Exactly. And then critically, a section for important things to keep in mind, or you could call them constraints. These are rigid rules the model must follow, like do not call tool X unless condition Y is met. Non-negotiables.
Okay, hard rules.
And a major takeaway, I think, is how they handle the output structure. This is crucial for integrating with other systems, other agents. You need predictable output.
Right, it needs to plug into something else.
Exactly. So they heavily use XML tag formats for this. Example tag, like this example tag.
XML. Interesting. Why XML?
Well, it turns out this format works exceptionally well, partly because many LLMs were actually post-trained on a lot of XML-like data, so they're surprisingly good at adhering to this structure.
Huh. So it's less like writing prose.
Yeah, much less like prose, much more like defining structured data for the model to fill in.
You're right. Seeing those XML tags, it definitely feels less like writing instructions in English and more like, writing code, but for a language model.
It really does blur that line.
So is this length and structure, this sort of code-like prompt, is this something companies are just manually writing out from scratch every time?
That's a great question, and it gets right to the heart of that tooling challenge we mentioned earlier. For the initial versions, yeah, it often starts manually, developers figuring out what works through trial and error.
Makes sense.
But this complexity leads directly into the scaling challenges. And actually, one interesting detail in this Parahelp example is what isn't in that core system prompt. Scenario-specific example outputs.
Ah, okay. So where do those go?
Those are handled later in their pipeline, apparently.
Right.
And this omission, it kind of highlights a key challenge for all these vertical AI agent companies, right? How do you build a general, scalable product when every single customer, whether it's Perplexity with their data or Bolt with theirs, has unique workflows, unique terminology, specific preferences?
Yeah, how do you build in enough flexibility for that special logic without just becoming a consulting shop, basically? Writing a completely new prompt for every client.
Exactly. You can't just build one-offs forever. That doesn't scale.
Right. This whole idea of needing to somehow fork or customize parts of the prompt for different users, different logic, and then maybe merge back improvements to the core prompt. It feels like the world is just starting to grapple with the engineering challenge here, managing prompts at this complexity.
Absolutely. And what we're seeing emerge is this kind of layered prompt architecture to handle it.
Layered, how so?
Well, you often see a system prompt. That's the most general layer. Think of it like defining the high-level API or the core operating principles for the company's AI agent product, sort of like the ParaHelp example we just walked through. That's the base.
Okay, the foundation.
Then, layered on top, there's often a developer prompt. This is where that customer-specific context comes in. How do you handle retrieval augmented generation, the RH part?
Right, pulling in specific data.
Yeah, how do you handle RH for Perplexity's knowledge base versus Bolt's completely different system? That specific integration logic, the customer-specific rules, that lives here. And this layer is usually highly proprietary. You won't see this shared publicly.
Got it. That's the secret sauce layer.
Pretty much. And then finally, there might be a user prompt. This is the actual input from the end user, but only if the agent is customer-facing. Like if you're using an agent on Replit, your request to generate a site with these features, that's the user prompt. But ParaHelp's core agent isn't end-user-facing in the same way, so their system kind of stops at that developer prompt layer.
Right, that makes sense.
And managing this whole multi-layered structure, especially at scale across many customers, it's complex. And this is where you see huge startup opportunities, I think, building tooling to automate parts of this process.
Like what kind of tooling?
Well, imagine tools that could automatically identify the best customer-specific examples from interaction logs, maybe based on success metrics, and then intelligently ingest them into the right prompt layers or maybe into the fine-tuning pipeline, reducing all that manual prompt tweaking.
Automating the feedback loop. That's smart.
Exactly.
That's actually a perfect segue, this challenge of constantly refining and managing these complex prompts. It brings us to a theme we hear consistently from AI startups, metaprompting.
Metaprompting, yeah, it's a really powerful concept that keeps coming up. It's essentially using one LLM to dynamically generate or, more often, improve another prompt.
Using an LLM to write prompts for another LLM.
Sort of, yeah, or at least to refine them. The core idea often revolves around something called prompt folding.
Prompt folding.
Yeah. You take an existing prompt, maybe you feed in some examples where it failed or produced, suboptimal results, and then you feed all of the original prompt, the failure examples, into a raw, often more powerful LLM, like a GPT-4 or Claude 3.7.
Okay.
And you ask that big LLM to act like an expert prompt engineer and help you revise or improve the original prompt. It sounds a bit meta, maybe a little weird.
It does sound meta.
But because the LLM kind of knows itself, its capabilities, its limitations, this process surprisingly works quite well.
Huh, that's clever.
And another really powerful technique, especially for very complex tasks, where writing out precise instructions in prose is just really hard, is relying heavily on examples.
Examples, yeah.
Feeding the LLM really hard, tricky edge case examples through a meta prompt turns out to be incredibly effective for steering its reasoning on complicated tasks. We saw the Jazzberry example for finding bugs in code.
Right, the automatic bug finding.
Yeah, feeding it hard examples like finding subtle N+1 query errors helps the model understand what patterns to look for, much better than just describing it in words. It feels a bit like test-driven development in programming, Write tests for the tricky cases first.
That's a great analogy, TDD for prompts.
Yeah.
And for you listening, a really simple way to try this metaprompting idea, maybe just as a hobbyist, is exactly that. Give an LLM the role of an expert prompt engineer. Ask it to critique your prompt.
Exactly.
You can run that loop, feed its critiques back in, ask it to improve it again.
Yeah.
And it can actually lead to significant improvements in your own prompts.
Absolutely. And there's a common pattern companies use leveraging this. They might use a bigger, more capable, but maybe slower and more expensive model, say Claude 3.7 or GPT-4 for that metaprompting step, to really refine and perfect the core prompt.
Okay, use the big guns for refinement.
Right. Then they take that highly refined prompt and deploy it in a smaller, faster, cheaper model like Llama 4 or maybe a fine-tuned open source model for production use, especially where latency is critical.
Like for voice AI agents, right?
Yeah.
They need to be fast.
Exactly. Voice agents need near instant responses, so you can't have a massive model taking seconds to think. Use the big model offline to craft the perfect instructions for the fast model.
Okay, so we've talked about the structure, the layers, how to improve prompts using metaprompting. But what happens when the prompt, no matter how good it is, just doesn't have enough information or context to actually succeed at the task.
This leads to maybe one of the most surprising but also critical discoveries that keeps coming up. LLMs are inherently designed to be helpful, right? Conversational. They want to give you an answer.
Aim to please.
They really do. And if they lack the specific information needed to make a determination or provide the output in exactly the format you requested, their default behavior isn't necessarily to just say, I don't know.
What do they do?
They might just, well, make it up, hallucinate. Or they might give you what they think you want in the format you asked for, even if it's based on faulty assumptions or incomplete data.
Well, that's dangerous.
It can be really dangerous, especially in high-stakes applications. So the critical solution, the necessary guardrail we're seeing implemented everywhere, is you must explicitly give the LLM an escape hatch.
An escape hatch.
Yeah, you have to hard-code instructions that say something like, if you do not have sufficient information to make a determination or complete the task as specified, STOP, do not proceed, do not guess, clearly state what information is missing and ask for it.
So you have to explicitly tell it how to fail gracefully.
Exactly. It's a fundamental shift in how you design these interactions. You're not just giving instructions for success, you're programming instructions for intelligent failure, asking for help instead of guessing.
That's a really different way of thinking about programming it.
It is, and we've even seen some internal work, for example, at YC, building systems where the LLM's output format itself actually includes a dedicated field for debug info.
Debug info from the LLM itself.
Yeah, but it's not just like a standard error log. It's essentially the model structured complaint back to the developer.
A complaint.
Detailing why it couldn't proceed. Maybe identifying confusing parts of the input, or pointing out underspecified instructions in the prompt itself. The output literally becomes a to-do list for you, the agent developer, telling you what to fix for next time.
That's mind-blowing. So the model isn't just failing silently or hallucinating, it's actively telling you how to make it better. That completely flips the debugging process on its head.
It really does. It turns failure into a constructive feedback loop.
Okay. And knowing whether the model is succeeding or failing reliably, that brings us squarely to the topic of evaluation, or evils. It's something people talk about, sure, but it still feels like a bit of a dark art for many.
It can feel that way, but what's absolutely clear from these sources and really fascinating is that the evils are the true crown jewel data asset for these companies. Maybe even more valuable than the prompts themselves.
More valuable than the prompt.
Yeah, think about it. PearHelp open sourced their prompt, right? But I bet you they didn't open source their evil suite. They told the researchers their evils are their secret sauce. Because without robust evils, you don't know why a prompt works or doesn't work in specific edge cases. You have no principled way to improve it systematically.
Right, the prompt is just the how. The evils tell you if and why it worked.
Exactly. And getting good evils requires something that sounds simple, but is actually incredibly hard.
What's that?
Deeply, deeply understanding the user's world. I mean, really understanding it. This means founders, engineers, product people, they have to get out of the building. They have to literally sit side by side with the people doing the specific knowledge work the AI is supposed to help with.
Like actually observing them work.
Yes. Imagine sitting with, I don't know, a tractor sales regional manager in rural Nebraska trying to decide on a complex warranty claim based on messy service history, or an FBI agent investigating complex domestic terrorism cases, sifting through mountains of unstructured data.
Wow, okay. Very specific context.
You have to understand their messy reality. The scattered Word docs, the overloaded Excel spreadsheets, maybe even fax machines still, the internal jargon, the office politics, and crucially, their reward function.
Their reward function.
Yeah. What does success actually look like for them in their job? How do they get evaluated? How do they get promoted? What are they optimizing for? And then the really hard part, you have to go back and codify all that messy reality into incredibly specific, measurable evils.
So an evil isn't just, did it answer the question correctly?
Oh, not at all. It's much more granular. It's like, given this specific invoice format, this customer's tangled history in this spreadsheet, and the current regional policy buried in that PDF, did the agent reach this precise outcome within these specific time constraints and adhering to these compliance rules? That level of detail, that granular codification is the moat.
Wow. That's a lot more involved than just checking accuracy scores.
It absolutely is, and it raises that question people often ask. Are these AI startups just thin wrappers around base LLMs like GPT-4?
Right. Is there real defensibility?
I'd argue emphatically no, not the good ones. The real value, the defensibility, is in this deep user understanding and the incredibly hard work of codifying that understanding into software, into prompts, and especially into evaluation systems that actually work for those niche specific users in their complex real-world workflows.
So the moat is the domain expertise codified.
Exactly. That ability requires this rare blend of deep technical skill and a willingness, an obsession really, to engage deeply with parts of the world's specific workflows that many technologists just never see or engage with.
This sounds remarkably similar to a concept we've touched on before, the rise of the forward deployed engineer, the FDE model. What can today's founders learn from where that model originated, places like Palantir?
Right. Palantir really pioneered this. The core thesis there was kind of revolutionary at the time. The biggest multi-billion-dollar problems, whether in government or finance or heavy industry, weren't typically accessible to the very best technologists because those technologists just weren't embedded in those environments.
They were siloed off.
Yeah. Palantir's idea was simple but powerful. Put world-class engineers' emphasis on engineers, not salespeople directly with the users, like sit them next to that FBI agent grappling with terabytes of messy data. They were there to help find the needle in the haystack live using Palantir's tools.
So embedded engineers solving problems on the ground.
Exactly. And the power was in the iteration speed. Instead of a long, drawn-out sales cycle with PowerPoint decks and requirement documents.
The traditional enterprise slog.
Right. The Palantir FDE would sit down, observe the actual workflow, identify a specific pain point, and then rapidly build a working demo using their Foundry platform. They could literally come back the next day or within a few days saying, okay, we built this specific thing to solve your specific problem, and they get immediate real-life feedback right there.
Instant feedback loop.
Totally. And that rapid iteration, building something users might not have even imagined was possible, and making them feel incredibly heard, which, by the way, requires immense empathy, design intuition, product sense, on top of top-tier engineering skills.
Yeah, it's not just coding.
Not at all. That whole package is how small, agile teams could bypass and actually beat massive incumbents like Salesforce, Oracle, or the big legacy consultants like Booz Allen, who are all stuck in those slow, traditional sales and development cycles.
And you can see exactly why vertical AI agents are turbocharging this FDE model right now.
Precisely.
A founder or an early engineer can meet with an enterprise champion, understand their specific pain point, and then quickly stuff that customer's specific context, their data examples, their workflow rules, their jargon directly into the prompt, or maybe into that developer prompt layer we talked about, and come back maybe the next day with a demo that's already significantly customized and incredibly relevant to that specific customer.
Exactly right. We see companies doing this successfully right now. Geiger ML, for example, they build voice support agents, recently closed a major deal with a company called Zepto. Or Happy Robot, building AI voice agents for logistic brokers, landing 7-figure deals.
Wow, 7 figures.
Using this exact model, they go on site, they work directly with the customer support team or the brokers to tune the AI on their specific data, their workflows, their accents even. They win these huge deals, not just because AI is cool, but because their demo is far and away the most impressive, the most relevant. It shows they've actually solved that difficult last 5–10% accuracy hurdle that generic solutions can't touch.
Because they haven't done that deep user embedding and evil work.
Exactly. They haven't codified that specific user's reality. And because they can show that working solution so quickly, they're closing these large enterprise deals at a speed that was pretty much unheard of for startups just a few years ago.
That FDE plus AI agent combo is powerful.
It really is. And, woven into all of this, the prompting, the evils, the user understanding, there's another kind of surprising realization that keeps popping up.
What's that?
Different LLMs, the base models themselves, they aren't just slight variations on a theme. They seem to have distinct personalities or maybe inherent biases in how they interpret instructions.
Personalities.
Yeah.
Like one is grumpy, one is cheerful.
Huh. Maybe not quite like that, but yeah, sort of. For instance, people often describe Claude models as maybe more compliant, more agreeable, perhaps more human-steerable.
Okay.
Llama 4, on the other hand, some folks say using it feels more like talking to a very literal developer. It needs super precise instructions, less ambiguity, maybe less flowery language.
Interesting.
Now, part of that might just be the training data or specific fine-tuning choices, but the difference is tangible when you're actually prompting them for specific nuanced tasks.
Do you have an example of that?
Yeah, actually, we saw a really striking example internally when we were experimenting with using LLMs to score investors based on a predefined rubric. We gave the exact same rubric to different models.
Okay, same input, same instruction.
Same everything. And the results were surprisingly different in how they applied the rubric. One model, O3, was incredibly rigid. It stuck strictly to the letter of the rubric, penalizing anything that didn't fit perfectly, almost like a soldier following orders precisely,
Why the book?
totally by the book. But another model, Gemini 2.5 Pro, was much more flexible. It applied the rubric, yes, but it also seemed to reason about exceptions or edge cases. It showed judgment, saying things like, well, technically this doesn't meet criterion X, but given circumstance Y, it achieves the intent, so I'm scoring it differently. More like a high-agency employee using their judgment.
Wow, that's genuinely fascinating because it maps so well onto how you might train different people for the same job.
Yeah.
You give them the manual, the rubric, but you also hope they'll develop judgment for the gray areas, the edge cases.
Exactly.
The fact that different models exhibit this kind of fundamental difference in interpreting and applying rules, that's a crucial detail for anyone building with them. It implies you really need to think about which model's personality fits the task.
It absolutely does. Is the task one where you need strict adherence or one where you value nuanced judgment? The model choice matters.
Okay, let's try and pull all of this together. We've really taken a deep dive today into the frontier of prompting AI agents, and it's clear it's evolving far beyond just writing simple instructions.
Definitely.
We've seen the detailed, structured anatomy of these production prompts, looking more like code with things like XML. We talked about the multi-layered architecture needed for scale system, developer, user prompts. Then the really powerful concept of metaprompting, where prompts actually improve themselves, almost like TDD for prompts, and the absolute necessity of building in that explicit escape hatch, telling the model how to fail gracefully when it lacks information.
Crucial.
We've dug into how the true value, the real crown jewels, might not even be the prompts themselves, but the robust evaluation systems built from that deep, almost ethnographic user understanding.
Yeah, the evils are key.
And how that deep understanding, combined with the forward-deployed engineer model, is letting startups build highly relevant solutions and close huge deals incredibly fast in specific vertical markets.
Unprecedented speed, really.
And finally, we just touched on this surprising reality that the models themselves seem to come with distinct personalities or reasoning styles that influence how they respond.
Yeah, understanding the tool itself.
It's a really complex, rapidly moving space.
It absolutely is. Working with these systems, it truly feels like navigating multiple eras at once. You've got the rough and tumble tooling vibe of the early coding days.
Right, like 1995.
Exactly. But you're also dealing with the nuances of communicating with and evaluating something that feels almost like a person sometimes. And then there are these echoes of principles like Kaizen, the idea that those closest to the work are best positioned to improve the process, which is kind of what metaprompting is doing, the LLM improving its own instructions. It's definitely a brave new world for software development.
It really is. So here's maybe a final thought for you, the listener, to chew on as you process all this. If the real moat, the essential advantage in this AI-accelerated world, is truly rooted in that deep user understanding and the hard work of codifying it into functional systems and evils, well, how could you get closer? How can you get proximate to the specific, messy day-to-day problems that real people face in their actual work? Because as we've seen today, getting close to that reality, understanding it deeply, that might just be the most valuable source of knowledge, the real alpha you can tap into right now.